Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be working out 27 practice test questions that should prepare you for the Arithmetic Reasoning subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, the pre-screening Internet Delivered Computer Adaptive Test, that is the PiCAT, the Air Force Officer Qualification Test, that is the AFOQT, and the Officer Aptitude Rating, that is the OAR. As far as your performance on this practice test goes, I want to say this: if you answer 80% or more of the questions correctly, that's considered outstanding, and chances are you're going to score very high on any of these tests. If you answer 70 to 79% of the questions correctly, I would consider that very good, and chances are you're ready to take any of these tests. If, however, you answer 60 to 69% of these questions correctly, I would consider that average, and that means you may want to spend a week or two studying the topics that appeared in this video. And finally, if you answered 59% or fewer of these questions correctly, that means you probably need to make some significant improvements in your math knowledge and your ability to do arithmetic reasoning. And in light of that, I would say you need to study for about a month. As a reminder, you're not permitted to use a calculator or a reference sheet on any of these tests. So as you work your way through these questions, try not to use any of those resources. Finally, I want to say that in the description of this video, there are going to be timestamps that are going to be associated with each question. Next to the timestamp is going to be the topic that the question's testing, as well as a link to a video of mine where you can learn more about that topic. In order to get the most out of this video, you'll also want to pause the video after I read a question, attempt to work out the question on your own, and then resume playing the video to check your solution. So with all that being said, let's go ahead and get started with today's video. All right, so number one here says there are 10 marbles in a bag, 4 are blue and 6 are red. What is the probability that a blue marble randomly gets picked from the bag? All right, so this is a problem testing your knowledge of very basic probability. And here's what you have to understand about that. We're looking for the probability, or P, of selecting a blue marble from the bag. And the way we're going to figure that out is we're going to take the number of blue marbles in the bag, and we're going to divide that by the total number of marbles in the bag. And as it happens, this math is very easy to do. How many blue marbles are there in the bag? There are 4. And how many marbles are there in this bag in total? Well, according to the problem, there are 4 blue ones and 6 red ones. So that means that there are 10 marbles in the bag in total. So the odds of picking a blue one are 4 out of 10. And unfortunately, we don't see that as one of our answer choices. So that should prompt you to come back to your answer here and think about simplifying it as much as possible. And you should recognize in this case that both 4 and 10 are divisible by a common factor of 2. Of course, 4 divided by 2 is 2. 10 divided by 2 is 5. And of course, that's answer choice A. In other words, the probability of selecting a blue marble from a bag that contains 4 blue marbles and 6 red marbles is 2 out of 5. All right, so that is that one. Let me say this. The ASVAB and all these other standardized tests are computer adaptive tests. So while you can see something as simple as this, chances are if you're doing well on the test, the questions may get more difficult. All right, so that is that one. Nothing too difficult there to get started. All right, so number 2 here says Jake is renting an apartment in Miami Beach for $1,800 a month. When the lease for his apartment expires next month, his landlord will increase his monthly rent by 2.6%. What will his new rent be per month? All right, so again, according to the problem, he currently pays $1,800 a month for rent, and we got to figure out what 2.6 added to 1800 is. So what we're going to do is we're going to take 1800 and we're going to multiply that by 2.6%. One reason people get this problem wrong a lot is simply because they fail to write 2.6% in decimal form. What is the decimal form of 2.6%? Well, that's going to be 0.026. So we're going to take 1800, we're going to multiply it by 0.026. All right, so let's work on that. If you haven't worked with decimals in a long time, here's what I want to say about them. When you multiply a whole number by a decimal, your goal is to clear the decimal from your problem. So in this case, I want to take the decimal and 0.026 and shift it 1, 2, 3 times to the right. And this problem becomes this: 1800 times 26, albeit with 3 decimals to move back into the left at the end when we're done here. So let's go ahead and work this out. We have 0 times 6, which is 0, 0 times 6, which is 0. 8 times 6 is going to be 48, so we're going to drop down an 8 and carry a 4. 1 times 6 is 6, plus 4 is 10. Before we start multiplication with this 2, we're going to bring in a 0 placeholder. 2 times 0 is 0. 2 times 0 is 0. 8 times 2 is 16, so drop down a 6 and carry a 1. 2 times 1 is 2, plus 1 is 3. Let's add this together now. 0 plus 0 is 0, 0 plus 0 is 0, 8 plus 0 is 8, 0 plus 6 is 6, and 3 plus 1 is 4. Let's bring our 3 decimal places back in. 1, 2, 3. So 2.6% of 1800 is 4680. To answer this one, we have to take 1800 and we have to add to that 4680. And now we're actually adding a whole number and a decimal. And if you haven't done this in a while, it can be a little bit tricky. So what you want to do is you want to take a decimal and place it here and add 2 0 placeholders. Now we can go ahead and add this as we normally would. 0 plus 0 is 0. Uh, 8 plus 0 is 8. Drop down your decimal in place. 0 plus 6 is 6, 4 plus 0 is 4, 8 plus nothing is 8, and 1 plus nothing is 1. So when we add 2.6% of 1800 to 1800, we can see that his new rent is going to be 1846.80, which of course is D. All right, so number 3 says a flagpole cast a shadow that is 28 feet long. A person standing nearby cast a shadow that is 8 feet long. If the person is 6 feet tall, how tall is the flagpole? So for this one, it might be helpful to make a little sketch. According to the problem, we have a person standing next to a flagpole. Of course, we know that the flagpole casts a shadow that is 28 feet long, and the person standing nearby cast a shadow that is 8 feet long. In addition, we were told that this person, which is right here, is 6 feet tall. And we want to know how tall the flagpole is. So the height of this flagpole is unknown, and in math, we typically represent unknown values with the letter variables. In this case, I'm going to let x refer to the unknown height of this flagpole here. Now, I just want to point this out. If you enclose these two figures, you create two right triangles. And that means you can actually use a proportion to compare these two figures. And here's how you want to fill in your proportion. You want to put all the information that you have on the left-hand side of the equal sign, and you want to put the information you're trying to figure out on the right-hand side of the equal sign. Well, what information do we have? We know that a 6-foot tall person cast a shadow that is 8 feet long. What are we trying to figure out? And let me stress this. This is the height of the person, and this is the height of the flagpole. Since I put the height of the person in the numerator over here, I'm going to put the height of the flagpole in the numerator over here, which is unknown, so we'll put x there, over 28. Now, in order to solve proportions, you simply do cross multiplication. So we're going to do 8 times x equals 6 times 28. I'm going to work this math off to the side so as not to make any mistakes here. 28 times 6 is 8 times 6 is 48, so drop down an 8, carry a 4. 2 times 6 is 12, 13, 14, 15, 16. All right, so this becomes 168 equals 8x. Of course, we're solving for x, which is the height of the flagpole. So we'll go ahead and divide both sides by 8 to get x by itself. And this math should be very easy to do. 16 divided by 8 is going to be 2. 8 divided by 8 is 1. So the height of this flagpole is 21 feet, which is answer choice B. Again, we had to realize that we were going to compare two similar triangles, which means we could use a proportion and some very simple cross multiplication to ultimately solve this one. All right, so as you can see, number 4 says how many feet of a wire fence is necessary to enclose a garden that is square and has an area of 225 square feet. So since we're talking about squares, let's go ahead and make one of those. This square represents our garden, of course. And for the ASVAB as well as other standardized tests, you have to recall some properties of squares. Notably that all the sides in a square are equal. So this side is equal to this side, that side's equal to that side, and that side's equal to that side. What's more, you should know that if this side's S, that means this side's S, and this side's S. So with those properties in mind, let's take a look at this problem one more time. We're told that the area of this square garden, our A, is 225 square feet. All right. What's more, we're being asked to figure out how many feet of wire fence will be necessary to enclose this square garden. Well, what does that mean? That ultimately means we want to know this length of fence plus this length of fence plus this length of fence plus this length of fence. In other words, we want to figure out what the perimeter of this square garden is. And that's going to be S plus S plus S plus S. So in order to go from having the area of this garden to finding the perimeter of this garden, we're obviously going to have to figure out what S is. And that's much easier to do than you think. Well, how do you find the area of a square? Area of a square is always S squared. That is side times side. We know what its area is, so in place of A here, we can put 225 equals S squared. Again, we just want S, not S squared. So to get S by itself, we're going to take the square root of both sides. This will cross out this square here, leaving us with S. And what is the square root of 225? Of course, that's 15. So S in this case is 15. Now that we know what S is, we can go ahead and plug it into our perimeter formula here. And this becomes 15 plus 15 plus 15 plus 15. And this math is actually very easy to do mentally. 15 and 15 is 30, plus 15 is 45, plus another 15 is 60. So in other words, the perimeter of this square garden is 60 feet, which means that you'll need 60 feet of fencing to enclose it. All right, so that is that one. All right, so number 5 says the price of gas in California is $5.25 per gallon. This is 175% of the cost of gas in Florida. How much does gas cost per gallon in Florida? All right, so thankfully enough, problems like these generally tell you exactly what operations you have to perform to solve them. In fact, the first thing you want to do is attempt to convert this word problem into an equation that you can then solve. And let's work on doing that. First, we're told that gas in California is 5.25 per gallon. Then it says that 525 per gallon is 175%. Well, in math, we typically associate the word is with equals. So that says 525 is or equals 175%. Again, more often than not, When you're translating a word problem into an equation, you're going to take percentages and write them in decimal form. The decimal form of 175% is 1.75. So let's add that to our equation down here. Of the cost of gas in Florida. Well, in math, we typically associate of with multiplication. So this becomes 1.75 times the cost of gas in Florida. How much does gas cost per gallon in Florida? That's an unknown, and typically we represent unknown values with letter variables in math. So the cost of gas in Florida is going to be X. So we're going to go ahead and add that to our equation as well. This says 525 is equal to 1.75 times X. If we solve for X, we'll know how much gas costs per gallon in Florida. So first things first, let's divide both sides by 175. This will cross out here, leaving you with just X on this side. And you might be able to do this one mentally, because let's think about it this way. What is 175 times 3? Again, we're multiplying a decimal by a whole number. So we're going to take the decimal and shift it 2 times to the right. This becomes 175 times 3. Once we work this out, we'll take our 2 decimals and shift them back into the left. 5 times 3 is 15, carry a 1. 7 times 3 is 21, plus 1 is 22. Carry a 2. 3 times 1 is 3, plus 2 is 5. Bring our 2 decimals back in. So 175 times 3 is 525. That means 525 divided by 175 is going to be 3. And in math, it's customary to write the variable for which you solved on the left. We can see that X is equal to 3. We know X refers to the cost of gas per gallon in Florida, so that X is going to be $3 per gallon. And we can see that the correct answer choice in light of that is A. All right, so that is that one. All right, so number 6 says during the holidays, a silver bracelet is on sale for $44. If sales tax is 6%, then what is the total cost for the bracelet, including sales tax? So for this one, it might be helpful to write a small equation to represent all the work you have to do to solve this one. And first and foremost, it should be pretty obvious that we're trying to figure out what the total cost of this bracelet is. And of course, total cost is going to include the original price of the bracelet plus the tax amount times the original price of the bracelet. And let's think about why that's the case. The original price of this bracelet is $44. And to figure out how much tax we have to pay on this $44, we're going to take our tax amount, which is right here at 6%. And more often than not, we're going to express percents in decimal form. Decimal form of 6% is 0.06, so this becomes 0.06 for our tax amount times our original price. And by doing this work right here, we'll know the total cost for this bracelet. So with that in mind, let's go ahead and start working this out. First, we have to work out 44 times 0.06. And as you can see, we're multiplying a whole number, notably 44, by a decimal, notably 0.06. As we've seen in this video already, we want to clear the decimal by shifting it to the right. In this case, we're going to shift it to the right 2 times. This becomes 44 times 6, albeit with 2 decimals to shift back into the left at the end when we're done. Again, we moved our decimals to the right here. When we work this out, we'll move our decimals back into the left. 4 times 6 is 24, so bring down a 4, carry a 2. 4 times 6 is 24, plus 2 is 26. Let's bring our 2 decimals back in. 1, 2. So this becomes 44 plus 264. And so as not to make a mistake doing this math, although many of you could do this one mentally, let's go ahead and do it off to the side. This is 44 plus 264. Of course, we're adding a whole number to a decimal. So what we want to do is bring a decimal here and a couple of zero placeholders. And if you really wanted to, you could put a zero placeholder here. 0 plus 4 is 4. 6 plus 0 is 6. Drop down our decimal in place. 2 plus 4 is 6. 4 plus nothing is 4. So we can see the total cost of this bracelet, including tax, is going to be $46.64, which is answer choice B. All right, so that is that one. All right, so as you can see, number 7 says a pumpkin pie was cut into 10 equal pieces. A person who eats one half of one piece eats what fraction of the total pie? So it should be pretty obvious that there are 10 pieces of the pie, which means that one piece is the equivalent fraction of 1 over 10. This 1/10 represents one piece of a pie that has 10 pieces. We want to figure out what one half of one piece represents. So we're going to take that 1 over 10, we're going to multiply it by 1 half. When you multiply fractions, you simply just multiply straight across. This becomes 1 times 1, which is 1, 10 times 2, which is 20. So if one piece of the pie represents 1/10 of the total pie, half of one piece of the pie represents 1/20th of the total pie, and we can see that is A. Just simple fractions there. I could draw a pie and slice it up for you, but this problem is so easy that you should be able to think about it this way. All right, so that is that one. All right, so number 8 says together a husband and wife earn $75,000 per year. If one of them earns $15,000 more than the other, what is the amount of the smaller income? So for a problem like this, your goal is to write an equation to represent what's going on in the problem. So in this problem, we're talking about the incomes of two people. That said, we don't know how much either of them earns. And in math, we represent unknown values with the letter variable x. So I'm going to say one of them earns X number of dollars per year. And let's go back to the question and see what else we can fill in. Uh, if one of them if one of them earns $15,000 more than the other. So this is one person right here. To represent the earnings of the other people, we have to translate this into our equation. We're going to take X, which is the earnings of our first person, and we're going to add $15,000 to that. All right, so here are the earnings of the second person. One person earns X number of dollars per year. The other person earns $15,000 more than that. In total, they earned $75,000 together, which looks like that. So now, all we have to do is solve for X, and we'll know our answer. And it should be pretty obvious that this first person, who just earns X number of dollars per year, earns $15,000 less than this second person. So this is going to be the amount of our smaller income. But that said, let's solve for X. We have X plus 15,000. X plus X is going to be 2X plus 15,000 equals 75,000. Again, we're solving for X, so what we want to do is subtract 15,000 from both sides. This will cross out here, and let's go ahead and do this math right here. Again, on this side, we just have 2X. 0 minus 0 is 0, 0 minus 0 is 0, 0 minus 0 is 0, 5 minus 5 is 0, 7 minus 1 is 6. So we have 2x equals 60,000. Now let's divide both sides by 2 to get x by itself. What is 60 divided by 2? 60 divided by 2 would be 30, and just tack on these 3 extra zeros. So we can see that the amount of the smaller income, which I said was X, is D, $30,000. All right, so that is that one. All right, so number 9 says if the population of a city decreased by 15% in 5 years, then the new population is what percent of the old population? All right, so tricky part about a problem like this is the fact that you have no information about the original size of the population or the new size of the population. So what you want to do is come up with values on your own. Beyond that, you want to pick values that are very easy to work with. So I'm going to say this is the old population and this is the new population. As a matter of fact, I'm going to say the old population of this city had 100 people in it. Well, according to the problem, we know that the new population decreased by 15%. So this is going to be minus 15%. So let's go ahead and figure out how we're going to determine what this new population is. We're going to take 100, we're going to multiply that by 15% in decimal form. What is the decimal equivalent of 15%? It's 0.15. So we're going to take 100, we're going to multiply that by 0.15. And then when we get this amount, we're going to subtract that from 100 to get our new population. As you can see, we're multiplying a whole number by a decimal. And what we want to do is move this decimal 2 times to the right, such that this becomes 100 times 15 with no decimals. And once we work this out, we'll take our decimal place and move it back into the left 2 times in our answer. So let's work this out. 5 times 0 is 0, 5 times 0 is 0, 5 times 1 is 5. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 0 is 0, 1 times 0 is 0, 1 times 1 is 1. Let's add these together now. 0 plus 0 is 0, 0 plus 0 is 0, 5 plus 0 is 5, 1 plus nothing is 1. Bring our 2 decimals back in. So we can see that our old population was 100. 15% of 100 is 15, which means the new population is going to be 100 minus 15 people. You should be able to do most of this work in your head, but I'm just working it out step by step. 0 minus 5 we can't do, so we're going to have to borrow from the left here. We can't borrow from a 0, so we're going to have to come all the way over here and borrow from this 1. This will become 0. This will become 10. Borrow one more time. This becomes 9. This becomes 10. 10 minus 5 is 5. 9 minus 1 is 8. So our new population is 85 people. All right, so we figured that out. And the question is this: what percent of the old population is our new population? So that's going to be 85 over 100. And we should know that 85 over 100 is going to be 85%. So the answer to this one is C, 85%. All right, nothing too difficult to work out there. The key, of course, was to set your initial population value to be a number that you can quickly use to figure out the answer. Again, you wouldn't want to set this to be like 111 or 157 because chances are, if you're pretty good at mental math, you could have pretty much solved this one without doing any work whatsoever. All right, but that's the logic behind this one. All right, so number 10, as you can see, says how many 10-pound bags of peaches can be made from 800 peaches if each peach weighs a quarter of a pound. So the first thing we have to do is figure out how much these 800 peaches weigh. Again, we know we have 800 peaches and each of them weighs a quarter of a pound. So we're going to take those 800 peaches and we're going to multiply it by 1/4. And as you can see, we're multiplying a whole number, notably 800, by a fraction, notably 1/4. In order to proceed, we can write 800 as a fraction by placing it over 1. And now we're just multiplying two fractions, which means we're going to multiply straight across. This is going to become 800 times 1, which is 800, divided by 1 times 4, which is 4. And this math is actually very easy to do. What is 8 divided by 4? That's 2. And then just tack on those two zeros. So in other words, our 800 peaches weigh 200 pounds. And the question is this: how many 10-pound bags of peaches can be made from these 200 pounds? So we're going to do 200 and we're going to divide that by 10. Of course, we can cross out these corresponding zeros. 20 divided by 1 is 20. In other words, we can make 20 10-pound bags of peaches. So the correct answer to this one is C. All right, nothing too difficult there, just some basic work with fractions. All right, so number 11 says it takes six small glasses to make a quart. If a glass is one quarter filled, what part of a quart is in the glass? And let me just say this, we're talking about glasses here, not cups. So this is not a conversion problem whatsoever. As a matter of fact, this is a proportion problem. And let me show you why. Again, proportions are nothing more than two fractions that are equal to each other. And when you solve proportions, you try to fill in the information that's given on the left-hand side, and then you try to fill in the information that you're trying to figure out on the right-hand side of the equal sign. Well, what's given? Right here it says it takes six small glasses to make a quart. So six glasses make one quart. What are we trying to figure out? If a glass is one quarter filled, that is a quarter of a glass, what part of a quart is in the glass? We know that we're going to have a quarter of a glass. And you may have noticed that across the equal sign, I kept my units the same. In the numerator over here, I have glasses. So in the numerator over here, I also have glasses. And we want to know what part of a quarter of a glass is. So that's unknown. And in math, we represent unknowns with letter variables. So I'm going to call that x of a quart. And as we've seen in this video already, we solve proportions via cross multiplication. So I'm going to do 6 times x, which is 6x, equals 1 times 1/4. Well, anything times 1 is just itself. So 1/4 times 1 is going to be 1/4. And clearly, if we solve this for x, we'll know what part of a quart 1/4 of a glass corresponds to. So to solve for x, we're going to divide both sides by 6. This crosses out here, and we're left with this 1/4 divided by 6. And at first glance, you might get lost as to how to proceed. But again, you can write all whole numbers as fractions by placing them over 1. So I can write 6 as a fraction by placing it over 1. And now it should be pretty obvious that we're just dividing two fractions. And let me go ahead and pull this off to the side. We have 1/4, that's one of our fractions, divided by 6 over 1. Well, how do you divide fractions? You follow the algorithm keep, change, flip. That is to say, you keep the fraction that's in your numerator the same. So we're going to write 1/4 as is. You're going to change from division, which this is a division bar, to multiplication. And then you're going to flip the fraction in your denominator. So instead of being 6 over 1, we're going to write this as 1 over 6. And now we're just multiplying two fractions, which means we're going to multiply straight across. This becomes 1 times 1 over 4 times 6. 1 times 1 is 1. 4 times 6 is 24. So we can see that x in this case is going to be 1 over 24, which is answer choice D. All right, so that is that one. We used a proportion to solve it. All right, so number 12 says the weight of two automobiles can be expressed as a ratio of 2 to 3. If the lighter automobile weighs 1,500 pounds, then how much does the heavier automobile weigh? So for this one, we're also going to use a proportion to solve it. And our proportion is going to look like this. Again, proportions are nothing more than two fractions that are set equal to each other. Of course, as I've mentioned in this video already, you want to fill in the information that's given on the left-hand side of the equal sign, and on the right hand of the equal sign, you want to fill in what you're trying to figure out. Well, what's given in this problem? We know the weight of the two automobiles have a ratio of 2 to 3, where 2 refers to the weight of the lighter automobile and 3 refers to the weight of the heavier automobile. What are we trying to figure out? We're trying to figure out the weight of the heavier automobile. And in math, we typically represent unknown values with letter variables. So I'm going to let x refer to the weight of the heavier automobile. So all we have to do is fill in this right-hand side accordingly. Again, this 2 corresponds with the lighter automobile, which weighs 1,500 pounds. And this X corresponds with the heavier automobile. And now that we have our proportion set up correctly, we're just going to solve this one via cross multiplication. We're going to do 2 times x, which is 2x, equals 3 times 1,500. And so as not to make a mistake, I'm actually going to work this off to the side. We have 1,500 times 3. 0 times 3 is 0. 0 times 3 is 0. 5 times 3 is 15. Carry a 1. 3 times 1 is 3 plus 1 is 4. So this says 2x equals 4,500. Of course, we're trying to solve for x, which is the weight of the heavier automobile. So we're going to be dividing both sides by 2 now. This crosses out here, leaving you with x on this side. Now, many of you could actually do this mentally, but that said, we could also read this as 4,500 divided by 2. And we're going to start this one by asking ourselves this. How many times does 2 go into 4 without going over? Of course, that's 2 times, given that 2 times 2 is 4. 4 minus 4 is 0. Now we're going to drop down this 5. Uh, and let's think about what we can do here. We can actually drop down this 0 and this 0 as well to make this 500. What is 500 divided by 2? Well, you should know that's 250. So 250 times 2 is 500. 500 minus 500 is 0. And since we hit that 0, we know we're done. So x in this case is 2,250. Of course, that is the weight of the heavier automobile. So the answer to this one is B, 2,250. So number 13 says a television show is 60 minutes long. During this show, there are 4 1 1/4 minute commercials. Approximately what percentage of the show is a commercial? So for this one, the first thing we have to do is find out how long these commercials run for in total. So we're going to add these 4 1 1/4 minute commercials together. So that's going to be 1 1/4. That's one of our commercials. 1 1/4. That's another commercial. 1 1/4. That's a third commercial. And 1 1/4. That's a fourth commercial. And you should recognize that this mental math right here is very easy to do. We have 1 plus 1 plus 1 plus 1, which is 4. Then we have 1/4 plus 1/4, which is 1/2, plus another 1/4 is 3/4, plus another 1/4 is 4/4. 4 divided by 4 is 1. So in total, there are 5 minutes worth of commercials during this 60-minute show. And if you wanted to, I could work this off to the side. Again, we know 1 plus 1 plus 1 plus 1 is 4, but what about 1/4 plus 1/4 plus 1/4 plus 1/4? Well, to add fractions, they all have to have the same denominators, which we have in this case. So then you write down that denominator, and then you just sum the numerator. So this becomes 1 plus 1 plus 1 plus 1. This is 4/4, which is 4 divided by 4, which is 1. So that's how I got the 1 right there. All right, so now we have to figure out what percentage 5 minutes is of a 60-minute show. So that's going to be 5 divided by 60, of course. And you should realize that we can actually reduce this fraction by dividing both 5 and 60 by a common factor of 5. 5 divided by 5 is 1. 60 divided by 5 is 12. All right, so unless you have this memorized, and I think it's a good idea to memorize a lot of common fractions, such as the fact that 1/4 is 25%, you can actually perform this long division to convert this fraction into a percent. And let's see what that looks like. Again, this says 1 divided by 12. Of course, you should recognize that 1 or 12 does not go into 1. So we have to add a decimal and a 0 placeholder. When we do that, we have to bring up a decimal into our answer. And since 12 did not go into 1, we have to put a 0 placeholder right there. Now 12 does not go into 10 either, so we're going to have to add another placeholder. And just in case we need them, we can add as many 0 placeholders as we want. All right, so now the question is, how many times does 12 go into 100? Of course, that's going to be 8 times. And if you can't work that out because you don't know your 12 times tables, you can do this. 12 times 8. Uh, 8 times 2 is 16, carry a 1. 8 times 1 is 8 plus 1 is 9. So 96 is as close as we can get to 100 without going over. So 12 times 8 is 96. 100 minus 96 is 4. Let's drop down this 0. Now the question is, how many times does 12 go into 40 without going over? Well, 12 times 2 is uh, 24. 12 times 3 is 36. So this is going to be 3. 12 times 3 is 36. 40 minus 36 is going to be 4. Drop down a 0. And you should see that this is going to repeat over and over again. So 1/12 is about 0.08333. Repeat it. And we should know that that is 8.3% approximately. So the answer to this one is B, 8.3%. All right, so that is that one. All right, so number 14 says Amy's current grades for her assignments in math class are 85, 90, 95, and 80. What grade does she have to earn on her next assignment to attain an average of 90? All right, so this is what's referred to as a missing value problem from an average. And let's try to decode this problem as best we can. Again, according to the problem, we know that Amy wants an average of 90. And let's talk about statistics for a minute. To find an average, which we call M in statistics, we find the sum of all the data points that we have, and we divide by the number of data points that there are. Well, in this case, the problem tells us she wants an average of 90, so we know her M has to be 90. In addition, we know what some of her test scores are already. Here's one, here's a second one, here's a third one, and here's a fourth one. And we want to know what she has to score on her next or her fifth assignment to obtain an average of 90. So let's go ahead and start plugging these values into the average formula here. Again, she wants a 90 average. So for M, we're going to put 90 right here. Let's sum all the data points that were given. We have 85 plus 90 plus 95 plus 80. And of course, we have to account for her unknown grade on her fifth assignment, which of course is going to be X. Again, in math, we represent unknown values with letter variables. We divide this by how many data points there are. There are 1, 2, 3, 4, 5, including the unknown one. So we're going to divide this by 5. All right, so should be pretty obvious that we're going to be solving this equation for x, which means the first thing we want to do is clear this 5 from our denominator here. This will cross out here and here, leaving you with 85 plus 90 plus 95 plus 80 plus x on this side of the equation. And if you don't want to make a mistake, since you may be a little bit nervous on test day, you can work this off to the side. This is 90 times 5. 0 times 5 is 0. 9 times 5, of course, is 45. So this becomes 450 equals 85 plus 90 plus 95 plus 80 plus x. All right, so you have a choice at this point. You can move each of these values over individually to get x by itself, or we can go ahead and sum these values. And personally, I recommend you do that vertically so as not to make any mistakes. So let's sum these together. We have 85, 90, 95, and 80. Let's go ahead and add those up. This is pretty easy. 5 plus 5 is 10, so bring down a 0 and carry a 1. Let's do this like this. Uh, 8 plus 1 is 9, so we have 9 plus 9 plus 9, which is 27. And then we have 27 plus 8. All right. 7 plus 8 is going to be 7, 8, 9, or 8, 9, 10, 11, 12, 13, 14, 15. So we're going to drop down a 5 and carry a 1. And 2 plus 1 is 3. So this becomes 350. So this equation becomes this 350 plus x equals 450. All right, so now we're just going to subtract 350 from both sides here. And my pen is starting to act up. This will cross out here, leaving you with just x on this side. 450 minus 350. You should be able to do that in your head, but if you can't, we'll do it the old-fashioned way. 0 minus 0 is 0. 5 minus 5 is 0. 4 minus 3 is 1. So x, of course, refers to the score she needs on her 5th assignment to have a 90 average in the class. And as we can see, she needs to get 100% in order to get that average. All right, so the answer to this one is D, 100. All right, so number 15 says, at a car dealership, a particular model comes in 4 trim levels, 5 different colors, and 3 different interiors. How many different versions of this car can be created from these options? All right, so this is a test of your knowledge of the fundamental counting principle. And the fundamental counting principle says this: when you're given different options, you can find the total amount of combinations you can create from those options by multiplying them together. So we have 4 different trim levels. We're going to multiply that by the 5 different colors we get to pick from. Then we're going to multiply that by the 3 different interiors that we get to pick from. And in doing this, this is going to tell us how many different versions of this car model we can create. And this math's actually pretty easy to do. 4 times 5 is 20. 20 times 3 is 60. All right, so the answer to this one is D. We can create 60 different versions of this car model. All right, so number 16 says Stephanie took out a loan for school that charges 8.5% in simple interest annually. If her loan was for $30,000 and she pays it back over 20 years, how much will she have to repay in total? So to answer a question like this, you're going to have to make use of the simple interest formula, which says interest can be found by multiplying your principal. Again, P is the amount of your loan, that's your principal, times rate, that's the rate of your loan. It's usually given to you as a percentage, times the length of your loan, or T, which stands for time. All right, and if you look through our problem, you can see that we have all those things. And this is just going to calculate the amount of interest that you have to pay back. In order to figure out how much you have to repay in total, you have to take your interest and you add that to your principal. All right, so first we're going to calculate our interest, and then we're going to add interest to our principal to figure out how much we're going to repay in total. All right, let's identify these things. Again, principal was the amount of your loan, and we can see that is 30,000. So this is 30,000. Rate is the percentage of interest that was charged on your loan, and we can see that's right here. It's 8.5%. More often than not, we express percents in decimal form. So this would be 0.085. So let's plug that in, 0.085. And what was the length of our loan? It was 20 years. So we have to work this out. 30,000 times 0.085 times 20. And it doesn't matter the order in which you work this out. As a matter of fact, I'm going to do 30,000 times 20 to get started. And as a matter of fact, I'm going to move down a little bit so I can work this off to the side. We have 30,000 times 20. So let's go ahead and take care of this. 0 times 0 is 0, 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 3 times 0 is 0. Before we start multiplication with this 2, we have to add a 0 placeholder. 2 times 0 is 0, 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 and 2 times 3 is 6. So let's add this all up. 0 plus 0 is 0. 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 And 6 plus nothing is 6. So we can see that this is 600,000. All right, so this becomes 600,000 times 0.085. All right, and this is where that 600,000 is going to shrink. So let's take our 600,000 and multiply it by 0.085. Of course, as you can see, we're multiplying a whole number by a decimal. So what we want to do is move this decimal in 0.085 to the right till we clear it. So it's going to be 1, 2, 3 times. So this is going to become 600,000 times 85, albeit with 3 decimals to move back into the left at the end when we're done. Again, we move those decimals to the right here. We'll move them to the left here. So let's work on this. Take your time as you do this. We've come this far, and we don't want to get this one wrong. 0 times 5 is 0. 0 times 5 is 0. 0 times 5 is 0. 5 times 0 is 0. 5 times 0 is 0. 5 times 6 is 30. All right. Before we start multiplication with this 8, we have to bring in a 0 placeholder. 8 times 0 is 0. 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 And 8 times 6 is 48. Let's add this all together now. 0 plus 0 is 0. 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 8 plus 3, that's 8, 9, 10, 11. Carry a 1. 5 plus, or 4 plus 1 is 5. And we're going to bring our 3 decimals back in. 1, 2, 3. All right, so we can see that the interest that we have to pay on this loan is $51,000. So let's add interest, which is 51,000, to our principal, which was 30,000. And this will tell us how much we have to repay in total. And this math should actually be pretty easy to do. You should know that 51,000 plus 31,000 is going to be 81,000. In other words, if you take out a loan for $30,000 and you repay it over the course of 20 years with an 8.5 interest rate, an 8.5% interest rate, you're going to have to repay 81,000 in total, and that means the correct answer is C. If you needed to, you could have done this off to the side like this: 51,000 plus 30,000. 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 0 is 0. 1 plus 0 is 1, and 5 plus 3 is 8. So that's how I got 81,000. All right, so that's simple interest. The math is very tedious, especially when you're working with big numbers. But as you just saw, none of it is especially difficult. Number 17 says, if the ratio of the side length of square A to the side length of square B is 4 to 9, what is the ratio of their perimeters? All right, so let's think about what this question's asking. First and foremost, you have to understand that we're being asked to compare the two side lengths of squares. And let's make a little square here and call this square A. And let's make a bigger square and call this one square B. According to the problem, the ratio of the side length of square A to the side length of square B is 4 to 9. Well, we should know some properties of squares, notably that all of the sides are equal. So in both of these squares, all these sides are going to be equal. And we want to make these side lengths such that they have a ratio of 4 to 9. Well, that's actually very easy to do. If I let this side be 4 and this side be 9, we can clearly see that square A's side length has a ratio of 4 to 9 with the side length of square B. All right, so we took care of that part. That's not that difficult to do. But now we have to compare the ratio of their perimeters. Well, how do you find the perimeter of a square? Well, if you remember what's on my reference sheet, you'd understand that to find perimeter, we simply add up all the sides of squares. And in squares, there are four sides. All right. So by adding up all the sides of square A, we'll know that its perimeter. And by adding up all the sides of square B, we'll know its perimeter. And then we can compare those ratios. Well, if this side's 4, this side's 4, that means this side's 4 and this side's 4. So let's find the perimeter of square A. That's going to be 4 plus 4 plus 4 plus 4. 4 plus 4 is 8. Plus 4 is 12. Plus 4 is 16. All right, so the perimeter of square A is 16. Again, if this side's 9, this side's 9, this side's 9, and this side's 9. So let's go ahead and fill these in accordingly. This becomes 9 plus 9 plus 9 plus 9. 9 plus 9, of course, is 18. Plus 9 is 27. Plus 9 is 36. All right, so let's compare these two perimeters now. I would say that the ratio of the perimeter of square A to the perimeter of square B is 16 to 36. Unfortunately, however, we don't see that as one of our answer choices. And here's why. We should know that both 16 and 36 are divisible by 4. 16 divided by 4 is 4, and 36 divided by 4 is 9. So as we can see, the ratio of their perimeters is 4 to 9, which is D, and of course, that's the same ratio as their side lengths. So if you see a question like this on the test, you should immediately know that in squares, the ratio of their side lengths is going to be the same ratio of their perimeters. All right, so that is that one. Nothing too difficult there. Just a lot of logic and reasoning to answer this one. All right, so number 18, as you can see, says an Acme computer chip can process 10,000 gigabytes of data in 20 minutes. An IBEX computer chip can process 12,000 gigabytes of data in 40 minutes. How many more gigabytes per minute does the Acme computer chip process than the IBEX computer chip? All right, so it should be pretty obvious that we have to compare the rates of data that each of these computer chips can process per minute. But that said, we're given rates in terms of 20 minutes as well as 40 minutes. So the first thing we have to do is convert the amount of work that the Acme and IBEX computer chips can do per minute. So let's start with the Acme computer chip. All right, so moving on, we know that the Acme computer chip can process 10,000 gigabytes of data in 20 minutes. To figure out its rate of processing per minute, we're going to do 10,000 divided by 20. Of course, we can cross out these corresponding zeros. This becomes 1,000 divided by 2, which is 500. So the Acme computer chip can process 500 gigabytes of data per minute. Let's go ahead and do the same thing for the IBEX computer chip. And according to the problem, it can process 12,000 gigabytes of data in 40 minutes. To figure out how fast that is per minute, we'll do 12,000 divided by 40. We can, of course, cross out these corresponding zeros. And this math is actually pretty easy to do. 12 divided by 4 is 3, and then drop down those two corresponding zeros. So it can process 300 gigabytes of data per minute. All right, and the question is this. How many more gigabytes per minute does the Acme computer chip process than the IBEX computer chip? Well, that's simply going to be 500 minus 300, which you should know is going to be 200. So the answer to this one is B, 200. All right, so that's that one. Pretty easy problem. Nothing too difficult there. All right, so number 19 says Ricky earns $12 per hour to mow his parents' lawn. On Saturday, he started mowing the lawn at 10:45 a.m. and finished mowing it at 12:25 p.m. How much will his parents pay him for his work? All right, so the first thing we have to figure out is how much of his time he spent mowing the lawn. And if you can't do that mentally, you could always work it out like this. We know he start mowing the lawn at 10:45 a.m. If we add 1 hour to that, that will bring us to 11:45. If we add 15 minutes to that, that will bring us to 12. And finally, if we add 25 minutes to that, that will bring us to 12:25, which is the time he finished mowing the lawn. So clearly, he spent 1 hour and 15 plus 25 minutes mowing the lawn. If you don't feel comfortable working that out mentally, you can always do it off to the side. We have 15 plus 25. 5 plus 5 is 10, so bring down a 0, carry a 1. 2 plus 1 is 3, plus 1 is 4. So he spent 1 hour and 40 minutes mowing his parents' lawn. Now, at this point, you're probably saying to yourself, well, I'm going to have to multiply this 1 hour and 40 minutes by 12 to figure out how much he should be paid in total. Of course, that's correct, but how are we going to do that? Is there something we can do to make this a little bit easier? And the answer to that is yes. We can actually write this hour and 40 minutes as a fraction. So we're going to have our 1 hour, and then we can write 40 minutes as a fraction over hours. So there are 60 minutes in an hour. So that means 40 minutes is 40 over 60 of an hour. Of course, we can cross out these corresponding zeros to make this 4/6. And of course, both 4 and 6 are divisible by a common factor of 2. 4 divided by 2 is 2. 6 divided by 2 is 3. So he spent 1 2/3 hours mowing the lawn. Now we can multiply this by his hourly rate of pay, which is 12. Now, here's where a lot of people might get stuck. In order to proceed, we want to convert this mixed number into an improper fraction. So we're going to do 1 times 3, which is 3, plus 2 is 5. So 1 2/3 as an improper fraction is 5/3. Of course, we're multiplying that by 12. Now, I can rewrite 12 as a fraction by placing it over 1. And now we're just multiplying two fractions, which means we're going to multiply straight across. Uh, 5 times 12 is 60, and 3 times 1 is 3. 60 divided by 3 is going to be 20. So his parents should pay him $20 for the hour and 40 minutes he spent working, if they're going to pay him $12 per hour for his work. All right, so the answer to this one is C, 20 bucks. All right, so number 20 says a steamboat can go twice as fast downstream as it can go upstream, and 3/4 as fast upstream as it could go in calm water. If it can go 30 miles per hour downstream, then how long will it take to travel 40 miles in calm water? All right, so you should recognize that this problem has all the elements of the distance formula. And the distance formula says this: D, our distance, can be found by multiplying rate and time together, that is R and T. And let's see what's given in this problem. If the steamboat can go 30 miles per hour downstream, well, that's a rate. Then how long will it take? Well, how long is referring to time, and that's an unknown, to travel 40 miles in calm water. Well, 40 miles is a distance. So let's start plugging those things in. We know our distance is going to be 40. Now, as far as our rate goes, we want to pay close attention to the wording of this problem. We're told that its rate is 30 miles per hour downstream, but we want to know how long it's going to take the steamboat to travel in calm water. So we can't necessarily use this rate. So I'm going to have to put an asterisk next to this rate, and that's going to prompt me to make a conversion at some point. And then, of course, it should be pretty obvious that we're going to be solving for t. How long will it take? All right, so we're going to be solving this for t. In other words, when everything's said and done, we're going to have t equal to something like that at the end. All right, so let's talk about the rates that were given in this problem. Uh, we're not told anything about these rates per se, but that said, we have three different types of rates. We have the rate of the steamboat in calm water, which I'll call C. We have the rate of the steamboat in uh, downstream conditions, which I'll call D. And we have the rate of the steamboat when it's going upstream, which I'll call U. Well, since these are unknown, we're going to have to work backwards to figure this out. I'm going to say its rate of speed in calm water is x miles per hour since we don't know what that is. Now, using that, we can go back and fill in the rest of these. All right, so it says right here, it can go three-fourths as fast upstream as it can go in calm water. So if it goes x miles per hour in calm water, that means it goes three-fourths x as fast upstream. And then it says it can go twice as fast downstream as it can go upstream. So that's going to be 2 times three-fourths x. And we can actually work this out very quickly. We don't necessarily have to do a lot to work this out, but we can actually write this 2 as a 2 over 1. So this becomes 2 over 1 times 3 over 4. Again, we're multiplying fractions, so we're just going to multiply straight across. 2 times 3 is 6, and 1 times 4 is 4. So this is 6 over 4x. So there we have it. We have our three rates. This steamboat can go x miles per hour in calm water, three-fourths x miles per hour upstream, and six-fourths miles per hour in downstream conditions. Well, we can actually use this 6 over 4x to figure out how fast this 30 miles per hour is in terms of the steamboat going in calm water. So again, we're told that it goes 30 miles per hour downstream. So we'll say 6 over 4x is equal to 30. And if we solve this for x, you should see that will give us the rate of the steamboat in calm water, notably x. So let's go ahead and solve this for x. Let's multiply both sides by 4 over 6. This crosses out here and here, leaving us with x on this side. And now we have multiplication involving a whole number and a fraction again. And I'm going to do that off to the side. This is 30 times 4 over 6. Again, I can write 30 as a fraction by placing it over 1. Then we're going to multiply straight across. This is going to become 30 times 4, which is 120, over 1 times 6, which is 6. And we should be able to do this math mentally. 12 divided by 6 is going to be 2, and then just bring down our 0. So clearly, the rate of this steamboat in calm water is 20 miles per hour. And now that we know that, we can go ahead and fill out the rest of this equation. Let me go ahead and box this off for you. We have 40. The rate of this steamboat in calm water is 20. And of course, that's times time. Now we're just solving for t, so let's divide both sides by 20. This crosses out, leaving us with t on this side. 40 divided by 20 is 2, so t in this case is 2. Of course, that's going to be in terms of hours, so that means it will take this steamboat 2 hours to go 40 miles in calm water, and we know it's going at a rate of 20 miles per hour. All right, so the answer to this one is B, 2 hours. All right, so number 21 says one pipe can fill a tank by itself in 8 minutes. A second pipe can fill the same tank by itself in 12 minutes. If the tank is empty, how long will it take both pipes to fill the tank together? All right, so this is a classic example of a combined rate problem. And if you look on my reference sheet, you'll see that I have some notes about combined rates. Notably, you can use this formula to figure them out. We have T over A plus T over B equals 1. And let me break this down. A refers to the amount of time it takes one thing to complete the task by itself. So right here it says one pipe can fill the tank by itself in 8 minutes. So we can let A be 8 minutes. So let's go ahead and plug that in. This becomes T over 8. B refers to the amount of time it takes the other thing to complete the same task by itself. And as you can see, it says the second pipe can fill the same tank by itself in 12 minutes. So let's let B be 12. And this 1 refers to the fact that we are completing one task. Finally, I want to point out that this T is the amount of time it takes both things to complete the one task working together. So, in other words, we're going to be solving this equation for T, and that will tell us how long it will take both pipes to fill the tank together. All right, so we should see that we're adding two fractions here. So we have to find a common denominator between 8 and 12. Well, you should realize that both 8 and 12 go into 24. So we're going to rewrite both of these fractions such that they have denominators of 24. To write 8 as 24, we would multiply it by 3. We're also going to do that to its numerator. 3 times 8 is 24. 3 times t is 3t. To write 12 as 24, we have to multiply it by 2, and we're also going to have to do that to its numerator. 12 times 2 is 24. 2 times t is 2t. Of course, this equals 1. All right, so now that we have the same denominators, we can simply combine these like this. 3t plus 2t is 5t. Of course, this equals 1. Now we're still solving for t, so we want to get rid of this 24 from the denominator. So we're going to multiply both sides by 24. This crosses out here, leaving you with 5t on this side. 1 times 24 is 24. Now we're going to divide both sides by 5 here. This will cross out here, leaving you with t. And now all we do is have to do this long division here. This says 24 divided by 5. All right. We start by asking ourselves, how many times does 5 go into 2? It doesn't. Now we move on and ask ourselves, how many times does 5 go into 24 without going over? Of course, that's going to be 4 times. And right away, you should know what your answer is. We have 2, 3, 4, and 5 as answer choices. This should be a clue as to which one's correct. 5 times 4, of course, is going to be 20. 24 minus 20 is going to be 4. And since 5 does not go into 4, we're going to have to add a decimal here and a 0 placeholder here. We're going to bring up our decimal and drop down our 0. 5 times 8, of course, is 40. 40 minus 40 is 0. So since we hit this 0, we know we're done. In other words, t is 4.8 minutes. So our answer is C, 4.8 minutes. In other words, these two pipes working together will take 4.8 minutes to fill this tank completely. All right, so that is that one. That is a combined rate problem. Number 22 says, on Tuesday, there were 100 pizzas sold at Romeo's Pizzeria. A large pizza cost $16 and a small pizza cost $11. $1,550 worth of pizzas were sold in total on Tuesday. How many small pizzas were sold? All right, so there's a clue in this one that's going to tell you how to solve it, and that clue is right here. We're given information about two different things. We're told that a large pizza costs $16 and a small pizza costs $11. When you're given information about two different things at once, that should be a clue that you're going to have to use a system of equations to solve a word problem like this. And let's work on writing our system of equations to match the information that's given in this word problem. So the first thing you want to do is label these two things. I'm going to call a large pizza X and a small pizza Y. So we know 100 pizzas in total were sold. So that means X number of large pizzas plus Y number of small pizzas were sold, and that's going to total to 100 pizzas sold. All right, so now let's take a look at the other information. We know a large pizza costs $16, so that's going to be 16x plus the price of a small pizza, which is going to be 11y. And we know that in total, $1,550 worth of pizza was sold. So by solving this system of equations here for y, which refers to small pizzas, we'll know our answer. So let's work on solving this system of equations for y. Uh, One thing you should realize is that if you take this top equation and multiply it by -16, when you add the result of that to this bottom equation, your x variable is going to go away and you'll be left with nothing but y's, which is what we want. And by the way, that's called the elimination method. The elimination method says multiply one or both of your equations by a constant, such that when you add the two equations together, one of the variables is eliminated. All right, so we're going to take this -16, we're going to multiply it here, we're going to multiply it here, and we're going to multiply it here. All right, and so as not to make any mistakes while I do that, I'm going to bring this down here. -16 times x is -16x. -16 times y is -16y. And -16 times 100 is going to be -1600. Of course, we're going to be adding this top equation to this second equation, which is 16x plus 11y equals 1550. All right. We can see that -16x plus 16x is eliminated. So in other words, our x variable is gone. Now we have -16 plus 11. Why? That's going to be -5y. And then we have -1600 plus 1550. Of course, that's going to be -50. All right, so now let's divide both sides by -5 to get y by itself. This crosses out, leaving you with y over here. A negative divided by a negative is going to be a positive, which is good. 50 divided by 5 is 10. So by solving this system of equations for y, we know that A, 10 small pizzas were sold on Tuesday. All right, so that is that one. Number 23 says, at Jacksonville's airport, a fueling truck can fill a gas tank at the rate of 250 cubic inches per minute. If a rectangular gas tank is 20 inches long, 15 inches wide, and 10 inches tall, how long will it take the fueling truck to fill this tank? All right, so there's a big clue in this problem as to how we're going to get started, and it's right here. We know that this fueling truck fills at a rate of 250 cubic inches per minute. All right, so given that that is cubic inches, we should associate cubic inches with volume. So ultimately, in order to figure out how long it's going to take this fueling truck to fill this rectangular gas tank, we have to figure out what the volume of this gas tank is. Of course, it's rectangular, which means it's a rectangular prism. And to find the volume of a rectangular prism, you should know that's length times width times height. And thankfully enough, we have all those things. We know it's 20 inches long, so that's our L, 15 inches wide, that's our W, and 10 inches tall, so that's our height. Let's go ahead and plug those values in. This becomes 20 times 15 times 10. And you can do this math however you want, as long as you multiply these three things together. That said, I'm going to do 20 times 10 to get started. 20 times 10 is 200. This becomes 200 times 15. And if you're not good at mental math and you don't feel comfortable working this one out mentally, you can always do it off to the side. I remember when I took the test, I was a little bit nervous, so I would probably work something like this off to the side. 0 times 5 is 0. 0 times 5 is 0. 5 times 2 is 10. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 0 is 0. 1 times 0 is 0. And then 1 times 2, of course, is 2. 1,000 plus 2,000 is 3,000. So the volume of our rectangular gas tank is 3,000 cubic inches. All right, so to figure out how long it's going to take this fueling truck to fill up this gas tank, we're going to do 3,000. That's the volume of our gas tank, divided by the rate at which this fueling truck can fill up a gas tank, which is 250. Of course, we can cross out these corresponding zeros, and this, of course, becomes 300 over 25. Now, you could make this a little bit easier. You should be able to recognize that both 300 and 25 have a common factor of 5. And here's why. 30 divided by 5 is 6, and just tack on that extra 0. So 300 divided by 5 is 60. 25 divided by 5 is 5. And we should know that 60 divided by 5 is 12. So in other words, it's going to take this fueling truck 12 minutes to fill up our gas tank. All right, so that is that one. Some basic work with volume. Number 24 says Phil has two cardboard boxes. The height of the second box is one half the height of the first box. The lengths and widths of the two boxes are the same. If the first box has a length of 10 inches, a width of 5 inches, and a height of 10 inches, then how much more volume does the first box have than the second box? All right, so it's pretty obvious that we're comparing the volume of two boxes. So I'm going to call the volume of this first box volume 1. I'm going to call the volume of the second box volume 2. And of course, boxes are nothing more than rectangular prisms. And if you look on my reference sheet, you know that to find the volume of a rectangular prism, it's length times width times height. And that's going to be the case for both of these since they are both boxes. All right, so we're going to find the volume of the first box, we're going to find the volume of the second box, and then we're going to say volume of the first box is this much greater than the volume of the second box. All right, so let's go ahead and do that. Let's start filling in this formula for the volume of the first box. We know it has a length of 10, so that's going to be 10. It has a width of 5 and a height of 10. All right, let's go ahead and work that out. 10 times 10 is 100. 100 times 5 is 500. So the volume of this first box is 100 or 500 cubic inches. All right, let's do the same thing for the second box over here. And let's take our time to make sure we fill this in correctly. We know the lengths and the widths of the two boxes are the same. This one had a length and width of 10 and 5, so we know this one's going to be 10 times 5. But that said, it says right here the height of the second box is half the height of the first box. Well, the height of our first box was 10. Half of 10 is 5. All right, so this becomes 10 times 5 times 5. 5 times 5 is 25. Uh, 10 times 25 is going to be 250 inches cubed. All right, so this one's actually pretty easy to do. We're going to take 500. We're going to subtract 250 from that. 500 minus 250, of course, is 250. All right, so to answer this question, the first box has 250 cubic inches more volume than the second box. So the answer to this one is D, of course. All right, so number 25 says a car dealership received a new shipment of 250 cars from the factory. Of 20 of the cars they received were Teslas, then what percentage of the total shipment was Teslas? So they received 20 Teslas out of 250 cars. To convert this fraction to a percentage, we're actually going to perform this long division here. That is, we're going to read this as 20 divided by 250. Of course, we can cross out these corresponding zeros, and this becomes 2 divided by 25. All right, so let's work that out using some long division here. We have 2 divided by 25. We start by asking ourselves, how many times does 25 go into 2? It doesn't. So that's going to prompt me to add a decimal and a couple of zero placeholders. I don't know how many zero placeholders I need, but I can add as many as I want. And once I add that decimal down here, I'm going to bring it up to my answer. And I'm also going to say this, 25 did not go into 2, so I have to put a 0 here to reflect that. Now I'm going to move on and say, how many times does 25 go into 20? It doesn't, so I have to put another 0 above 20 to indicate that 25 did not go into 20. Now the question is, how many times does 25 go into 200? Of course, that's going to be 8 times. And let's think about this. 25 times 4 would be 100. Therefore, 25 times 8 would be 200. Of course, 200 minus 200 is 0. And since we hit this 0, we know we are done doing our long division. And this is 0.08. Of course, 0.08 is the same thing as 8%. For much of this video, we were going from uh, percents to decimals, it should be pretty easy to go from a decimal to a percent. So the answer to this one is D, 8%. So number 26 says in 2020, 1/8 of the senior class graduated with an A average, 1/2 graduated with a B average, and the rest of the class had a C average. In a class of 800, how many of the students graduated with the C average? All right, so this one's a little bit tricky, and you can see that we're going to be working with fractions again. But that said, let's break this down. We know that we're going to be working with one graduating class in total, so that's going to be one. We know that 1/8 of the graduating class graduated with an A average. So from our total class, we're going to subtract 1/8. Half of the graduating class had a B average, so that's minus 1/2. And by performing this math right here, we'll figure out what fraction of the class had a C average. That is to say, when we do 1 minus 1/8 minus 1/2, that will tell us the fraction of students that graduated with the C average. So let's go ahead and work this out. As you can see, we're subtracting fractions now. And in order to add and subtract fractions, they have to all have the same denominators. Well, let's rewrite 1 to be a fraction by placing it over 1. So we can see our denominators are 1, 8, and 2. Of course, a common denominator is going to be 8. 1, 8, and 2 all go into 8. So we're going to rewrite these fractions as needed such that they have denominators of 8. All right, so uh, to write 1 as 8, we'd multiply it by 8. We're also going to have to do that to its numerator. 1 times 8 is 8. 1 times 8 is 8. So 1, which is the same thing as 1 over 1, is also 8 over 8. 8 divided by 8, of course, would be 1. This one already has a denominator of 8, so we're just going to bring it down as is. To write 2 as 8, we're going to multiply it by 4, and we're also going to have to do that to its numerator. 2 times 4 is 8. 1 times 4 is 4. All right, so now that our fractions all have the same denominators, we can go ahead and rewrite this like this. This all over 8, then we have 8 minus 1 minus 4. In other words, this is going to be 8 minus 5 over 8, and 8 minus 5, of course, is 3. So this is 3 over 8. So 3/8 of the graduating class had a C average when they graduated. So we're going to take 3/8 and multiply that by 800 to figure out what the actual number of students was that graduated with the C average. And this math is actually pretty easy to do. We have 3/8 times 800. We can write 800 as a fraction by placing it over 1. And before we do this multiplication, we can actually say 8 goes into 8 one time, 8 goes into 800 100 times. So we have 3 over 1, which is 3, times 100 over 1. 100 divided by 1 is 100. 3 times 100 is 300. All right, so the answer to this one is C, 300. So number 27 says during spring, a hardware store had a 20% off sale. If a lawnmower originally cost $400, how much does it cost during the sale? All right, so let's write an equation to figure this one out. It's going to be very simple. We're trying to figure out what the sales price is. So we're going to take the original price of our lawnmower, and from that, we're going to subtract the discount amount times the original price. And it's really that simple. And thankfully enough, we have all these things. We know the original price was $400, so that's going to be our original price. And our discount amount is right here. Of course, as I've mentioned in this video, I think 4 or 5 times already, we typically express percents in uh, decimal form, and 20% in decimal form is zero point 0.2. So that's our discount amount. This becomes 400 minus zero point 0.2 times 400. And by working this out, we'll know what our answer is. I'm going to do this off to the side so as not to make any mistakes. We have 400 times zero point 0.2. And as you've seen in this video already, when we're multiplying a whole number by a decimal, we want to clear that decimal. So in this case, we want to shift our decimal 1 time to the right. And this becomes 400 times 2, albeit with one decimal to move back into the left at the end. 0 times 2 is 0. 0 times 2 is 0. 4 times 2 is 8. Bring our one decimal back in. So this becomes 400. And my pen is starting to die here. We just figured out that 0.2 times 400 is 80. And if you're not comfortable doing this math in your head, even though you should be, we're going to do 400 minus 80 like this. 0 minus 0 is 0. 0 minus 8 we can't do, so we're going to have to borrow. This is going to become 3. This will become 10. 10 minus 8 is 10 minus 8 is 2. And 3 minus nothing is 3. So we can see that the sales price of this lawnmower, when it has a 20% discount, is going to be $320, which is B, of course. All right, so that is it for this video. It was a long one, but that said, you should benefit quite a bit from it if you watch it from start to finish. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. Want to stress this again. As long as you answered 60% or more of these questions correctly, I would consider that a good thing. And in light of that, you may want to spend an additional week or two studying at most. Um, if you want to help my channel out, please consider subscribing to it. And on that note, I'm going to go ahead and cut you loose.
Konnichiwa.